Hey everyone, thanks for joining our webinar. And uh, our webinar is called Beginner's Guide to Evolution, RAG Evolution with Professor Tom. And I will be your moderator today. My name is Yukti Divedi, and one of my main jobs here at SingleStore is to organize weekly AI webinars. And we organize maybe two, maybe three webinars per week. So just stay tuned for the next ones. Just give me a second. I'm having a little bit of issue with my screen. Oh yeah, so if this topic is interesting to you, we have multiple topics coming up. So we have on September 4th, Trillion Row Speed Test. So this is a very interesting webinar that is hosted by Eric Hansen from the product team. So if that is interesting to you, feel free to register, and they will actually come up with a database that consists of trillion rows, and we will be assessing the speed of SingleStore DB and how it's able to process that much of data. So stay tuned for that. And on September 5th, we have how to talk to your SQL data with function calling. And on September 9th, we have augment your DB to speed up and scale your SaaS apps. So if any of these topics are interesting to you, feel free to RSVP right now, and I hope to see you all there. So moving on, anyone who tries out SingleStore today will be able to be enabled to enter for a chance to win either branded new AirPods or Meta's new Ray-Ban smart glasses. So simply click the link that's present on your screen, or just scan the QR code. It will directly take you to the landing page and be eligible to be entered to win. I will be putting everything in the chat as well, and we will be announcing the winner by the end of the session today, and one more winner by the end of the day. So stay tuned for that. And moving on, I would like to announce our speaker today. So we have Mr. Tom from University of Colorado and Boulder. He is an expert and has been like doing webinars with us in the past as well, and they have been really popular. Thanks for joining us, Tom. And we also have Akmal, who is here an expert at SingleStore. He's a senior technical evangelist. Thanks for joining, Akmal. And I will be passing the mic to him first, and just to talk a bit about SingleStore. So, Akmal, this is my screen. If you're comfortable, I can do the slides.
Yeah, I think that's better. You see, you can keep that.
Okay.
Okay, so if
Okay.
you just forward on to the next slide, there we go. I think we've just got like two slides that we normally show. This one is the kind of the standard one, which is the nice kind of overall sort of vision, if you like. So if we look at the company and where it's come from, well, on the left-hand side, we can see 2011, founded as MemSQL. So both the product and the company used to be called MemSQL, and Mem kind of, giving you an idea of where it was the sort of position really was in memory for OLTP. And subsequently, we can see between 2015, 2016, added support for columnar store, OLAP, and subsequently this kind of universal storage, if you look a little bit ahead between 2019, 2020. So now we've got a single table type that can handle both types of processing, both OLTP and OLAP. And just in the middle there, roughly 2017, you can see vector search plus full text search. So vector search, vector capability and support has been in the product actually for quite some time. Originally, it was stored as a blob type, which, yes, it worked fine. But earlier this year, we added support for a dedicated vector type and also sort of approximate nearest neighbor indexing. Okay, so previously it used to be sort of KNN, which was great, worked well for sort of millions, tens of millions of records, and you get an exact sort of correct answer based upon the data. But think about it: if you scale up, say hundreds of millions of vectors or even billions, then you come to a point where it's got something like that even may slow down. So having an indexing mechanism can work really well. And so ANN gives you the benefit in terms of speed, but what you lose is accuracy. And if you're willing to forego that, and it's a trade-off. I mean, if you need to make fast business decisions and you want the answers quickly, then having this kind of ANN indexing is going to work really well. But the fact is you may not get entirely 100% correct answers. And just as an FYI, for those of you that are kindly attending today, that I think Yukti has something in the pipeline in the very near future. We'll actually be doing a dedicated webinar just on vector indexing, looking at the various types and looking at some examples and the recommendations that we make as a company in terms of our product, and giving you some examples of that, actually applying it to some data. And then just to wrap up there, so we are a $100 million ARR, annual recurring revenue, company, and over 350 customers. I think that's up to 370 now, plus global customers. So along the bottom, you can see some of our investors. So it's a bit like that story that I often tell. It's like the gentleman who went and bought a shaver, and he liked the shaver so much he went and bought the company. So some of our investors were actually our customers. They liked the product so much they decided to invest in us. And that's where that comes from. So that's kind of a nice overview in terms of where the company has come from, and some, in terms that we are around. We are not just a fly-by-night company, and we've been here for a while, and we are continuing to grow. Okay, Yuki, next slide, please. And I think that will probably be great just to wrap up. So in terms of where our focus is, we like to think of kind of three things: transact, analyze, and I always have terrible time pronouncing this, contextualize. Okay, there we go. So it's about transactions, which we talked about, super fast. For OLTP, we are a scale-out distributed SQL database, shared nothing architecture, horizontally scalable, columnar support, great for OLAP, great for the sum, min, max, average, these kind of aggregate functions. And we have multi-model support as well. Okay, by that we mean it's not just relational types, but we support geospatial, time series, JSON, vectors. Obviously, we mentioned that already. And even I think there's a customer using us for key value. I mean, how's that for a relational system being used for key value? And then the vectors there at the bottom there in terms of semantic search as well. So the other thing that, just to conclude there, is that you can use SingleStore with full text search as well. So you get the benefits of both. And if you were fortunate enough to attend the workshop that I did on the recommender systems just recently, one of the notebooks that we shared, which was, I think, the last one, shows you how you can combine full text search with the kind of semantic search. So you're relying on the vectors to help you with one part of the query and the full text to help you with another part of the query. And our full text search is based on Lucene, okay, the open source Apache project. Okay, I think that should be a good summary there, Yukti. So with that, I will sort of exit from there now and assist Yukti in answering the question. I'll hand over to Tom, who will take us on with his session now. So over to you, Tom. Thank you, sir.
Hello, thank you all for joining the webinar today. We're going to talk about RAG evaluation, and thank you, Yuxi and Egmont, for supporting me in this webinar. All right, so today I'm going to share my screen, and I'm going to sketch most of my content. Just bear with me to figure out how to share. And what I'm gonna do is I'm also going to turn off the video for now, and I'll come back during the Q&A so that I could save some bandwidth and also be less distracting. So, okay, so I'm gonna turn off my video and share my screen. Already did. I think I already did. Okay, cool. All right. Okay, Akmal, if there's any technical issue, please just turn on the microphone and just yell so I can hear. Otherwise, I might not be able to see what's going on.
Okay, thank you, Tom. We'll do.
Okay. All right, so let's dive in. Beginner's Guide to RAG Evaluation. And my name is Tom Yeh. I'm an associate professor at University of Colorado Boulder. And today, it is my honor to be hosted by SingleStore to talk about this topic. And as I was preparing for the webinar, and I did a little poll to get a sense of where the interests are. And by the way, I have a slides available on this website, byhand.ai, by-hand.ai/reg-eval, and you'll be able to download the blank PDF version of this slide. Some of you, I mean, many of you have told me that you like to have those slides available so you can sketch together with me during or even after the talk. I believe this talk is being recorded. And the poll is sending a very clear message. People care about tools. You care about tools. And also you care about, come on. All right. I'm back. I know it will happen. The Zoom just crashed. All right, so the message was clear. You like to hear about tools? Come on, what's going on? Tools, you like to hear about matrix. So that will be the two main topics I'm going to talk about. I'll start with tools and then I'll cover matrix. But before I go really into the RAG evaluation, I'd like to give a quick overview of what RAG is. So RAG stands for Retrieval Augmented Generation. And the way that I like to illustrate RAG is as follows. We'll start with an application such as a Q&A or a chatbot. A user might have input, for instance, a question. The user asks what pets. And if we have large language model, typically we could also just send directly to a generator, a large language model to generate a response. But then and then we experience a lot of problems like hallucination and stuff like that. And very quickly we realize it's not a good idea to send the user question as is to the large language model. Instead, we like to augment it with something else before we send it over. So we have a question here. We want to augment it with something else. And what would be the something else we want to augment this question with would be context. Now, where can we get the context? We're going to use the retriever in this case. And this retriever will take what pets as a query and then probably work with some kind of database, for instance, a vector database, something like SingleStore or some other vendors, and get some information. And this say that it is like a pet shop. We're trying to build a chatbot for the pet shop, and this shop has inventory of a particular kind of pet, and so it going to retrieve, for instance, oh, we have a small cat, and here we also have maybe red frog, and then maybe we also carry some big dog, and then this exotic pet shop with snake, and also some mini pig. So these are the information that provides the kind of context that we could augment the query with, and then together, where is it? And then we could send the whole thing to the generator, and the generator could then answer the question based on this augmented query. And for instance, the generator might say, oh, dog and cat and maybe bird, good example of pets. So this is RAG. We have R, retriever, and we have augmentation is A, and with generation is G. So that's what RAG is. All right. It's hopefully is a good review of what RAG is. And then now we're trying to analyze and assess the performance of this RAG system. And one of the really useful data is called a trace. We want to trace exactly what happened during this operations of the RAG I just demonstrated for you. And so this is that's how I will manually trace. I'm gonna use a highlighter and trace trace this again. So we'll start with the user question, and going down, we would like to do some augmentation. But first, I would like to retrieve this context. So this is retrieval. And then as I'm doing that, I'm querying a vector database. I would need my question, which is the prompt, to be converted into an embedding vector. And this is the prompt embedding step. And then we'll hit the vector store and to get this kind of stuff. So the vector store, and then we'll augment this context by encoding the context with augmentation. So this step, and eventually send the whole thing for generation and get some result. So the generation. So that's how I would manually trace, but you also write your code. You can add a lot of triggers or a log statement into each one of the steps and to get this the information you need. Later on, you can apply statistics, some matrix to compute some matrix. And if you think that writing this log and keeping that around in the database is pretty tough, use tool. And the one tool I really like is LangFuse. So I'm going to go through some overview of some of the key features of LangFuse tools. It might be helpful. And this is no doubt very popular. It's 5.4 star. And then preparing for this tool, I would like to give special thanks to Mark, who talked we spend some time together going through some demo and hear about the vision and history and story behind lane views. I was really impressed. So thank you, Mark. So lane views, let's go back to the tracing example I just did. So with lane views, like as I'm tracing through it, it's going to do that for me. So it's a QA app. Now I have to retrieve. So start with retrieval and do some prompt embedding and hit the vector store and get a bunch of information. And then we encode the context together for augmentation together with a prompt and get a particular prompt from a set of prompt template, eventually generate. All this is locked very nicely by the lane views tool. You have this nice timeline view at each iteration, each transaction of this rack operation. And then, so let's do a live demo. The way I like to do live demo is really like to do live demo by hand. That's how I do it. So this is a chatbot. Suppose you have a RAG application, a chatbot, and this is an application that to answer your question about lane views based on the documentation of lane views. But anyway, I'm gonna ask a question. I care about pet. The first question is like, what are some good pets? I'm gonna enter this query into this chatbots, and I'm gonna click on the send and get a response. Sorry, I don't know how to help with that. Well, it is a chatbot to help you understand lane views. It's really not about a pet store, so it's to be expected. Okay, I'm gonna ask another serious question. Maybe like, what is a trace? And I click. I'm gonna get this. Then I get this result. A trace in lane views represents a single request of operation within your application. And it's a lot of stuff. All right. So I have just had this two operations or two interaction with this RAG chatbot. And behind the scene, if we use a tool like lane views to log what's going on, this is like this really big table. It added just two new entries that represent my two interaction with this chatbot. And this is some kind of usage numbers and some session ID and user ID and so on. And then I'm gonna maybe take a look at one of the trace. And this is a trace when I ask my first question, what are good pets? And sorry, I don't know how to help with that. So that is that dot. You can see that it's being locked. And on the right-hand side is that timeline view I just showed you earlier. And this is some of the statistics. I'm gonna look at it just in a moment. But for now, I would like to allow to compare the two different interactions. One actually got some good answer. The other one didn't get any good answer. So if we look at the traces, we can start to understand the behavior, what differentiate these two cases. So on the left-hand side, I have what are good pets. On the right-hand side is what is a trace. And in this case, I'd like to just highlight one of the operation in the timeline. For instance, initially we are at over here, QA, and this is one step. I just highlight this prompt embedding step. The prompt embedding step is to take the question, what are good pets, or what is a trace, and turn into a vector representation. And the output is actually, it doesn't have a text representation because it's going to be a vector of numbers. And the model that's being used is not a large language model, it's actually an embedding model. It's text embedding ADA002 from OpenAI. And this number show you this, we have number 5 is a prompt tokens. Why do we get number 5? You count this number, 1, 2, 3, 4. What are good pets? Question mark is 5. What is a trace? Question mark. It happens to be 5 as well. And then we have no completion token because we only get a vector in return. So this behavior, once you look at it, it does make sense. It matches your expectation as you implemented this RAG. And now look at the next step, vector store. And it's being logged as well. In the vector store, we get input is that this thing. What is this thing? This is actually an array. This is also an array of numbers. So it is a really long vectors. Okay, and then some number I want to point out here is that you have this number 1535. What does it tell you? It tells you something about the model dimension of your embedding vector for this sentence. The dimension. What is dimension? Is 1535, which is not correct. It's actually +1 because it's a 0 base. And that's first math you're gonna get from me. I'm doing a lot of math today. So it makes sense because the ADA, the small embedding model from OpenAI, it has the dimensions is 1536. You know it's doing the right thing. And vector store supposed to be taking input vector used with the same dimension. If you happen to feed this to a vector store that you have a different dimension, there's something wrong. So you have to debug. In this case, for who are good pairs, let's talk about retrieval. And there's nothing got retrieved. In this case, what is a trace irrelevant to the lane-fuse documentation. So in a database which has stored a lot of documents that will be able to retrieve something like this, you can already see the difference. And then let's look at the next step. The next step is the generation. Let's just skip to the generation step. For my generation step here, so that's the number one to highlight here is that on the left-hand side, you can see, we have completion token, that 11 of them, and 212 of them for the right-hand side, and that matches the response we get here. For here is that the response is, sorry, I don't know how to help with that. It's 11 tokens, and here we have the trace is a comprehensive representation of a single request or operation, blah, 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 bunch of bullet points. It's about 212 completion tokens. And now look at the prompt. So this is a system prompt. In this case, it does not retrieve any context. It's a system prompt about 94. In the case of context of 938, you might ask yourself, why do we have a lot more tokens here? Why do we have more tokens? 938 for the prompt. The prompt is bigger. But this prompt it says you are a very enthusiastic language representative who loves lane-fuse representative who loves to help. Blah blah blah. It's not 938 words because there are a lot more context being embedded, being augmented. So these numbers need to match up. It retrieves some chunk from the documentation being indexed. So this is the implication of the number of tokens that you send it to OpenAI model or some other vendors. In the case of who are good pets, is 94 plus 11. In the case of what is a trace, is 938 plus 212. You can kind of see that 212 corresponds to this part, 938 corresponds to this part. So there's a way you can analyze your application in this way. And lastly, look at some metrics. So lane-fuse computes some building metrics. For the left-hand side, you get the conciseness is equals 1. And 1 is a really good score. It's actually perfect. Why is it really perfect being scored as concise? Because it doesn't know the answer. It just tells you, sorry, I don't know how to help with that. Very concise, very short answer. It doesn't provide a lot of explanation or excuses why I cannot help with that. It doesn't say something like, oh, I'm not a pet store. I'm just a assistant. So it doesn't say anything like that. Very concise. Whereas on the right-hand side, it's not as concise as 0.2 because there's a whole bunch of stuff. I just want to know what is a trace. Actually, I just want to have a really short and concise answer, but it's give you a long answer. And look at another one, helpfulness. Even though the first on the left-hand side, the answer is very concise, but it's really not that helpful at all. Sorry, I don't know how to help with that. It's not helpful. So it's to be expected. We got 0 here. But on the right-hand side, it says a lot of stuff, and some of the stuff it turns out to be quite helpful. So it's 1 is 1. So you can already see here, there's a trade-off between, tend to get trade-off between conciseness and helpfulness. The more concise you are, the tend to be most helpful. The most concise answer you can possibly have, you say nothing. It's super concise because nothing, but it's also extremely not helpful when you don't say anything. Okay, and then you can also be very, very not concise, say a whole bunch of stuff, but it's be really helpful because it has lots of information in it. All right, so this how I give a big overview, a quick sense of how you might be able to use a tool to help you handle all the traces, the collection of traces, and get some really high level rudimentary metrics like conciseness and helpfulness and so on. There's other things. You can read the documentation. And I'd like to bring you under the hood to see how exactly the implement the ability to evaluate conciseness is actually uses another language model that use evaluate and write the system prompt to do that. So this is an example. I like the open source project like Langfuse because I can actually read the source code. I go to the source code and know exactly how they implemented what the template is used to measure conciseness. So I just copy the code from here, evaluate block. Imagine you are writing this prompt. You have to write this prompt. Imagine evaluate the what of the generation on a continuous scale from 0 to 1. So what would be the right word for that prompt? So it turns out it's pretty straightforward. The right word is conciseness. So that is the prompt for doing that. And specifically for information requested without including unnecessary, irrelevant, or excessive detail. So that's how it is. And let's go back a little bit. I want to highlight how can I tell? I actually know. So and then on the UI you can actually see that you could select a model to evaluate conciseness. It's a GPT-4o model. It has a reputation to be faster but cheaper. So that might not be the same model you use to implement your RAG. I don't know what the chatbot, the Langfuse demo chatbot was implementing as. They might use a different model. But then this is a model that use for the evaluation for conciseness. Okay, so that is Langfuse. And then how can you use Langfuse for your project? For instance, if you use a tool like Llama Index to build your to build your RAG application, and it turns out it's just one line of code to do that. It's hard to believe, but it is one line of code. So I'll show you how does it work. So you suppose you have Llama Index apps already, but what you do is that you will get Llama Index import to import this thing called callback manager. So Llama Index has a callback mechanism that anytime something that happens, they'll just call back to provide a callback trigger. Then you can hook that with some log statement with the trigger to do that. And the callback manager is going to be set the callback manager with the setting here. So that's where the Llama Index gonna be here, Llama Index. And then from the Langfuse, what we're gonna do here is Langfuse will import from here. What we import is the special handler. It implements Llama Index callback handler. And then we'll just take it as argument here, Llama callback index. And then it could get fused together connection. I just like to draw like this to show you how two things eventually meet in one line of code. And with this handler, it's going to send all the log statements and traces into data into the into the cloud. Or you can also self-host this open source tool, Langfuse. You can host on your own as well. It will and then will generate. You'll be able to access all this UI GUI to do some cool analysis if you want to. And now that I show you a bunch of individual examples and traces, how you could use to get some basic metrics like conciseness. And then what if we would like to compute a bit more like you have a data set level, you have lots of transaction and traces. You like to get a statistic, summarize that performance into a few statistics and for you to be able to make sense for you, also for explain others. So the next tool, or for a particular metric, I want to introduce is this tool called RAGAS, and which stands for RAG as assessment. RAG assessment. If you that, I guess maybe the right pronunciation is RAGAS, because it's a RAG assessment, right? And I would like to give special thanks to Shahul, who we got the chance to talk about RAGAS. I get to learn more about. It's a popular tool, 6.3 stars, and now they are seeing like 20 million evaluations in their cloud systems on a monthly basis. It's pretty important, impressive milestones. Okay, so the RAGAS score, that is the very now as a the the diagram they share on their website, that it provides a so-called this component-wise score that is split up the score into the generation portion and also the retrieval portion. And then this is like a most 4 top most used metrics. And that is a way to show that there are 4 different scores. There are other metrics as well, but for this one, the 4 major ones. So I'm gonna go through the more details how these are calculated. But I'll start with the first one, faithfulness. Faithfulness is how factually accurate is a generated answer. So again, this is a generation about a generator score. And so I have this worksheet to go over the calculation for the faithfulness metric. And faithfulness metric that I went through the process of RAG. We got some context, also got some answer. For faithfulness, so we want to see that whether the context, the retrieval is about the context. Our generation is about, are we able to generate answers? This is a generated answer. That is the answer relevant, is based on, is faithful to the context that is being retrieved. So what I'm gonna do is that to evaluate, go through each statement and see whether that actually faithful to the context. For instance, for dog, is dog, let's click the highlighter. Is dog, come on, I use the green highlighter, erase. Is dog can be inferred from a context? Now look at the context, yes, can be inferred from here. Is can cat be inferred from the context? They look at it. Oh yeah, it can be inferred from here. How about bird? Can bird be inferred from the context? In this case, we actually cannot. So I'm gonna use let's no gray. So black is to denote that it's not inferable. So it's not as faithful. So in this case, now I have this equation I can compute. So how many are inferable? How many of these 3 statements are faithful to the retrieved context? In this case, I have 2 of them. And then and how many are not? So it's 1. So if we add this all up together, is 2 over 3. And so the answer is equals 2 over 3. So this is our faithfulness score. And the perfect score will be 1 if the birds also happen to be the context, and they will be pretty faithful, right? And then, so the flip side of the coin of faithfulness is hallucinations. Hallucination is that is really not in the context, but somehow the generator just includes it, generates that as part of the answer. In this case, our bird. For some reason, the large language model, the generator thinks that bird is supposed to be the answer. But if we look at the context that's being retrieved, it doesn't have bird in it. So that is hallucination. So we work out this equation. There will be 1 here and 2 here, and equals 1 over 3. So hallucination score is bad. Faithfulness score is good. And you can also notice that these 2 have the relationship of they add up to 1. So the flip, that's why I said the flip side of the coin of hallucination, faithfulness is hallucination. Okay, so that is faithfulness. Let's look at the way that how I was highlighting this dog and cat with highlighter. And in practice, I was doing it by hand, but in practice, you do not do it manually. Fortunately, right now, the large language model is so powerful, we even delegate this sort of a labeling task to the language model. So again, I like open source project because I can see the source code. So this is a system prompt Ragas use to implement faithfulness metric for making the judgment. And so let's read this together. Your task is to judge something. What do you think would that be? To judge of a series of statements based on a given what? Okay, so it's judge the faithfulness. Well, this seems to be pretty straightforward. Based on the given context. So we go back to our example here. Come on, how do I shift? So that this is the context. And then we're judging, this labeling is pretty much judging faithfulness. So this is just good enough for us. If I was a graduate student, I have to do all this judging myself, but now I can get a model to do the judging to calculate the face muscle score. All right. So let's look at the next score under the generation column, answer relevancy. How relevant is the generated answer to the question? So what we would like to do is compare this answer to our question to judge whether they are relevant. But in this case, that not trying, there's a uses like really interesting idea that instead of directly asking that, oh, is the answer relevant? It's trying to do this indirect process. That's I'm gonna explain in a second. So I'm gonna ask a model to take the answer again and trying to reverse engineer from the answer. What would be the answer question? What could be a question asked based on this answer? Think about dog, cat, bird. What could be the different question people might ask? The answer would be dog, cat, bird. So this generator gonna think about a little bit. Maybe it could be the same model, could be a different large language model, and just generate a bunch of questions. Let's read this question together. First is that after seeing dog, cat, bird, okay, probably what are common pets could be one question because that's what they have in common. They all could be pets. What are domestic animals is another fair question. And what are small animals? They are also kind of small. It's also a fair question given this answer. And now we have these three questions. We compare to original question. In this case, they will be able to use more like non-large language model tool to compute this, use sentence embedded to compute their similarity. And for instance, what are common pets and what pet, and we use similarity using cosine similarity. And just as an example, we get 0.9. It's kind of close, pets and pets. And what are domestic animals? Kind of close, animals and pets, but not as close to 0 to the first one. So we're going to give a score slightly lower, 0.8. What are small animals? What are pets? Some not that similar, but it's still not completely dissimilar. So we can, just as an example, 0.4. So we have 3 cosine similarity score. Then we compute the average of the 3. So add them up. So get 2.1 and divide it by, because it has 3 model generates 3 variants of the questions, and they get 0.7. All right. So that's how I use just do some hand calculation to illustrate how RAGs compute answer relevancy. It's slightly more complicated, but then also indirect, but they seem to work quite well. That's how we could use it to be used by reverse engineering from the generative answer and to see whether that reverse engineer question matches the original question for measuring relevancy. Now we look at how exactly that feature will implement. Again, going to the source code, I found this prompt. It says that's what it says. So it says that generate something for a given answer and identify if the answer is something. So generate a question. So that's what I was just doing by hand to generate 3 questions. But it turns out there's a problem of this generation. In this case, I have an answer is like pet, is a dog, cat, and bird. But what if the answer was like, sorry, I cannot help you, like in the name fields example I showed you earlier. So there will be a kind of like a non-committal answer. It's difficult for you to generate any question from non-committal. So I ask you, I don't know. What would be the question for I don't know? There could be lots of questions. So it's important to know that it is a non-committal question. If that's the case, we found the question is not, the answer is actually non-committal. The answer is non-committal, like I don't know. So we might have to do some further processing. So you can see that writing this prompt is not trivial. It's not just like, oh, generate question, but there's a lot of trial error. You realize the original system prompt doesn't work. You add this non-committal clause to your prompt. So, all right, let's move on to the retrieval side of the score. First, I'm going to talk about the easier one, the recall. Can it retrieve all the relevant information required to answer the question? So context recall gives you the matrix about that. In this case, is a retriever matrix. So in this case, actually, I need some ground truths. So I need to know what pets and given this context, the ground truth would be well, the ground truth, I just an example. Maybe I would like the ground truth to be dog, cat. Someone actually write a ground truth question is fish. This actually done by human, rabbit. So this is my ground truth according to, I have a pet shop. This is actually what I have in my store. So there's a ground truth. And retriever, I want to test retriever can retrieve this 5 different chunk. 1, 2, 3, 4, 5 chunk here. How relevant they are, how much of the information in the ground truths are actually show up in our retrieved chunks. And so one thing I'd like to bring your attention to is I'm gonna use a highlighter and black one. This is retriever matrix. In fact, we actually do not need to consider this part. So I just gonna cross it out. I'm not consider this. I'm only going to pay attention to the retrieved context and also the ground truths. And then now I'm gonna do some labeling. Now I want to label whether they are like relevant to. So let's look at the retrieve result. These are ground truths. And then is dog in the retrieve result? Okay, here. Is cat also in the result? Yes, here. Is pig is the result? Yes. Is a fish in the result? No. And is rabbit in the result? No. In the turtle in the retrieved result context? No. So I have 3 out of 6. They are recalled in the context by retriever. So if I bring up my pen, so this is 3 are relevant plus 3 is not relevant. So only 3 out of 6 statements in the ground truth are retrieved successfully. So recall is actually 3 out of 6 equals this 0.5. Let's think about a little bit. How can we improve recall? One way to improve recall is that instead of including only 5 chunks, I can just keep adding more chunks. Eventually, at some point, if I'm lucky, maybe fish is over here and turtle is over here. So if that happened, my recall goes up. But what would be the trade-off here? If I just increase the chunk, it becomes less precise. If you look at all these 20 chunks, only very few are actually relevant and useful. So we need another metric to look at the other side. That's why the precision comes in. So the very typical information retrieval, precision versus recall. You might heard of the trade-off. Is a signal to noise ratio of retrieved context. And going back to this, I probably label them with something that inferable from context, something they are not. Given now we have only 5 chunks. So precision is that how close we want those retrieved relevant chunk to be as close to the top as possible, top 1. Ideally, they are all within top 5. So instead of having the fish down here, we want this fish to be as close to the top 5 as possible. So this is what the retriever, the context precision metric is trying to measure how close our relevant chunk can be to the top. And so again, I'm going to do this exercise again, is to make an emphasis, put emphasis on the fact that this is a retriever matrix. So all this part could be safely ignored. Okay, we'll only pay attention to this and the context and also ground truth. Now bring my pen so I could fill this the equation. This is probably the most complicated math you'll get to see before I do solve you today. So relevant. Let's think about K 1, 2, 3, 4, 5. The first one in code is it relevant or not? So 1 is relevant, but 2 frog's not relevant, 0. 3 is relevant, not relevant, and relevant for pig is relevant. And then I want to compute the true positive at K. And this is we can ignore because they are not relevant for this equation. Ignore, you can skip here. So true positive at K equals 1, true positive is 1. And true positive, K equals 3 here is 2. I've got 2 of this. True positive is 3 is actually 3. So it turns out it's just adding, accumulating the number. And now the context position is this number over K. So 1 over K is 1. 2 over K is 3. And 3 over K is 3 over 5. And then this is 1, 0.67, and 0.6. And you take an average. In this case, we divide it by n is 3. Only 3 are relevant in our top 5 results. So when added is 2.27 and over 3 is 0.676. So this is how we'll compute context precision. If you are in the class of like data mining and stuff, you heard about this word map, mean average precision. That's exactly how we'll calculate by hand. Hopefully, they're taking the course, this exercise might be helpful for you. And again, let's look at how exactly it's being implemented in RAGAS. So they use in the precision, they write the system prompt saying given question, answer, and answer and context. So we need question, answer, and context. And verify if the context was useful in arriving at a given answer. Given worthy as 1 if useful and 0 if not, with the JSON output. So going the equation, it kind of matches what I was doing by hand. 1, 0, 1, 0, 1. That's why we have that. We need this statement. If useful, 1, not useful, 0. And then when I'm labeling this purple, it's about, is this useful? Is small cat useful for the ground truth answer? Dog, yes, it is useful. Is red frog useful? Not useful. Big dog useful? Yes. Snake useful? Not useful. Mini pig useful? Yes. So that's how the retrieval matrix for context precision. They will use the same label to compute recall as well. All right. So now think about cost. So now you realize that there are some costs associated with it. This evaluation, they don't come as free because they will have to hit a large language model to do the judgment as well. And all those will cost money. You need to get a sense of which part of this evaluation operation would rely on a large language model. So this is exercise that I prepare just to practice, give us how we could understand where the large language model is being used. So in this case, look at the generator matrix. So generator matrix, we focus on this part. And so where are large language model used? So when we have the generated result, of course, this will be used for generation. So generation being used right here. Let's use a different color for now. So I use a different color, maybe use yellow. And for evaluation, you might, when you're actually doing this labeling, sorry, not dog does not match the dog. Dog match big dog. So this evaluation will hit the large language model, and this also hit, and this also bird define nothing. So these are 3 evaluation calls to the large language model API to carry 3 extra calls. And generation is something you just have to spend because when you serve the user the responses. So then it makes sense that come on, what's going on? Oops. Okay, so this you want to be like, you can use expensive models. Expensive one, because this is like this to serve the user, and for evaluation, you use a cheaper model for evaluation. And let's look at the generator matrix side of things. So you can perform similar analysis, but first of all, very quickly, you can cross this out. You don't have to consider this because we are evaluating the retriever, and then we can do the analysis of the cost. So all this label comparison, 6 of this 6 statements all hit evaluation. So I have 6 different evaluation, but no generation for this particular case. So anyway, this is just to visually highlight the fact that depending on the metric, what you want to evaluate, which component you want to evaluate, is it the retriever, is it generation, has some impact of whether the metric will be costly, how much you might have to spend using the models to perform the evaluation. And there are many, many more metrics that I did not cover today, like context utilization, context entity recall, noise sensitivity, answers, just this RAGAS tool. And there's other papers like RGB, RAG checker, a whole bunch of stuff, that dozens of metrics. And so And I create this table to kind of show you that when you pick the matrix, what kind of question you want to ask yourself. So if it is the first question is that, is this evaluating generator or retriever or blah 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 or both? And does it use evaluation large language model evaluate? So in this case, all the four matrix I just covered all use large language model to assist instead of using cheap graduate student like myself many years ago. Does it involve ground truths? So the first two generator, we don't need to use ground truths, and then we need ground truths for evaluating these two for retrievers. And the range of values, in this case, is between 0 and 1. It's some kind of ratio. And in this case, the best score is 1, 1, 1, 1. And there's a lot of them that you could fill this table, but I haven't really done that. But I can give you a sense of why there's not obvious. For instance, answer semantic similarity. It does not require large language model. Noise sensitivity has a range of 0 to 1.0, but the best score is actually 0 because we would like to minimize noise. And domain-specific variation is on scale 1 to 5 instead of 0.1, and the best score is 5. So this is an answer, the question you have to ask yourself as you evaluate, as you pick a evaluation metric. You want to know that what is the best score, what is the range. You can actually compare apple and orange. So at the end, which metric should you use? I probably would say that it will based on your need, your customers, that because you do want to be able to explain to your customer that why the metric you are targeting matters. You might not need to really use an obscure metric. Instead of using an obscure metric that nobody understands, you might use a common metrics like faithfulness, answer relevancy, because these are being made really popular by RAGA's tool, and you'll be able to communicate it better with other teams, other people, VCs, and your collaborators, and so on. All right. So this is kind of all I have for the evaluation. And I'll move to the question answering session. We have about 7 minutes left.
Thank you for the amazing session. This was really helpful. And so Akmal has been doing a great job taking care of the questions. So Akmal, if you feel like anything's relevant, feel free to point it out and we can have Tom answer the questions. So for anyone that still has a question, feel free to put it in the chat using the Zoom Q&A button, which is present at the bottom of your console. So we will try to take up all the questions that we can live. And if we are not able to take them live, our apologies, but we will follow up with you afterwards via email. And if you have a question that has to be taken offline, you can reach out to us at team@singlestore.com. So yeah, take it away, Akmal.
Okay, so there's a couple of questions there, I think for Tom, which I couldn't answer, unfortunately, because I wasn't looking at what Tom was presenting. I was too busy looking at this. So Harsh has a question, which was fairly early on in the presentation, Tom, and the question was, what does metadata signify here? Can this be used for key document identification? So I'm guessing that's something you covered right early on, Tom, possibly. I don't know if you recall. Reference to metadata. Does that ring a bell?
Not exactly sure about what the question without the context. So if I'm just answering right now, I'm almost like hallucinating because I don't have the right context.
Yeah.
So hopefully, but then if I get to ask for retrieve some relevant context from Harsh, and that will help me improve the faithfulness of my answer.
Okay. All right. So we'll see if Harsh can add a bit more there. And I think there was another question here, which was sort of fairly early on from Eugenia. It says, why correctness in the left one is low? The agent answer correctly as it was told to answer that when the question is out of context. Again, that happened fairly early on in terms of your presentation, Tom. So again, I don't know if that rings a bell with you.
I see. So you might refer to what I bet the question was referring to what are good pets. then we sent this question to a chatbot. The chatbot was specifically built to answer documentation of lane views. So that, but somehow because they are testing the whole generation pipeline, and when they was being fed to another model, the model think that, well, what are good pets? This very easy question to answer. We all know they are dogs and cats. How can you not help? If you are a useful assistant to answer questions about the documentation, you're still a human being. You could answer general common sense question. So maybe that is why the models think differently. But again, we're trying to relegate this assessment to models. We're not saying this is not to be published on paper or academic paper. It does not need to precise what's very, very accurate. But what matters is about the relative metrics that today versus tomorrow versus the day after tomorrow. Is your metric improving? Even though the metric is approximated by a large language model, they're trying to help you assess. It does not matter. It doesn't need to be 97% is exact. As long as they are, you can see the trend, allow you to catch the trend. If there's a dip in your metric, you know there's problem.
Great, thank you. Wasim has got a question here, Tom. It says, what are other methods apart from RAGAS to evaluate RAG? Are they context and industry specific too, he asks.
So there are a lot of other options, and I create this table to give you an idea that when you approach to a particular metric, so these are the questions you should ask yourself. They all specify somewhere in the documentation, but I have not aware there's a nice organized table to tell you that. So if you're interested, you could reach out to me. I could use some help to create a table like that. And that would be really useful for the community, like a go-to resource to compare all the metrics in one central place. Maybe SingleStore can host that.
Yeah,
that table.
We'll think about it. See if we got some resource for that. Thank you for the suggestion, Tom. Tom, Igor's got a question. It says, can you evaluate only questions? What about evaluating function calls?
So if we want to evaluate the question is about evaluating function code. So I have not come across during my study that metric specifically for function code. So there, my best guess is that when you want to evaluate function code, is more on the generator side. So you might apply the generator metrics as to get the overall performance, the idea about overall performance. And then because it's function code, you can also run more traditional testing, like regression testing or behavioral testing, then into your pipeline.
Okay, great. Here's a good question from Sriram. He says, how is ground truth determined?
How is the ground truth determined? So the ground truth for retriever, because when you evaluate retriever, you don't have anything generated from the generator. So ground truth, it tend to be, you have to just hire people to do it.
Yeah.
Or based on your actual customer complaint. So lane views, for instance, that is about half of the uses in the is about production. So when you put your chatbot out there, you can always get customer questions in a way that you can never imagine. So once it come in, your matrix suggests that you fail and you hire your own people to, then you provide the right answer. Over time, you accumulate more and more ground truths as you go. And every time they can help you, you can rerun the metric and with more ground truth, and to know that your retriever system is actually getting better and better.
Yeah. Great. Thank you very much. I'm conscious of time. Yukti, we're almost at the top of the hour. I think it's half past the hour for you in India. So maybe it's a good time to wrap up and give our thanks to Professor Tom Yeh for another superb and awesome session. I think I see quite a lot of people asking, will the video recording be available? Yes. So if you registered, you'll get a follow-up email with a link to the recording. And Tom already provided the link to his slides and resources for the by hand, which I think Yukti posted in the chat anyway, but I think you'll include that with a follow-up email, won't you, Yukti? So there we go. And I just hand back to you then. And Tom, any further thoughts? Any further
I
comments?
just want to thank you for being an amazing host again. So I can only do this because you're answering question in the background for me.
You're welcome. You're
And
most
also
welcome.
thank you for all the audience for attending this webinar. And please send me any feedback about how I can improve some of the content. I hope this information, this knowledge could be really helpful for the community.
Yeah, absolutely. Great. Thank you very much. So Yukti, over to you then, if I hand you back there to wrap up.
All right. Thanks, Tom. Your webinars have always been so amazing, and I'm really looking forward to doing more with you. So, people that are attending, please fill in Tom's inbox with the request that, hey, we need to do another webinar. So, thanks, Tom, and thanks everyone for attending. Quick notes before I will announce today's raffle winner. So, Akmal, can you please share your screen with the slides that I shared earlier?
Yes, bear with me one moment. Let
So,
me.
meanwhile, when Akmal is sharing the slides,
Oh dear.
any feedback regarding the session, if there's any suggestions, any ideas on topics that you would like to see in future sessions, please feel free to connect with me on LinkedIn to stay on top of the loop, because I also post about these webinars that we are hosting here and now. So, and in general, if you have any feedback, our inboxes are open. Feel free to reach out to us anytime. And yeah, just again, I'm mentioning again, we are going to send out the recordings. So yeah, if you're not getting the emails, you can reach out to us at team@singlestore.com. And thanks everyone for joining. So if you are interested, you can join us again on September 4th. We are doing Trillion Row speed test with SingleStore, which will be hosted by Eric Hansen, who's an expert here at SingleStore. And on September 5th, we have how to talk to SQL data with function calling. And on September 9th, augment your DB to speed up and scale your SaaS app. So if any of these topics are interesting to you, feel free to RSVP right now, and I will see you all there. So the announcement that everyone's been waiting for, the raffle winner, it goes to Anjali Samani. She is a senior director at Salesforce. So congrats, ma'am, and thanks for joining.
Right.
And if that is not you, as promised, we are going to announce one more AirPods winner and Meta's Ray-Ban winner by the end of the day for anyone that has tried out today's demo. So sign up at the link that has been provided to you in the chat. And if you don't have it, I can actually, I'll just repost it, because I've realized that Zoom somehow it just erases the messages. So if anyone that joined late, it's there in the chat again. And feel free to try out SingleStore notebooks to be eligible to win. We will announce one more winner by the end of the day. Once again, thank you, Tom, and thank you, Akmal, for handling the Q&A so well. We really value everyone's time and energy. And thanks everyone for attending. Have a great rest of the day, great rest of the night, wherever you are. Take care, everyone. Bye-bye.
Bye-bye.